I, I love that song, and I love music, but I think most people here would say that it's actually their sight that is their most important sense. We use it to navigate the world, we stare obsessively at our phones, and it's intimately associated with our most important memories. And I'm sure many people here can quickly recall a trip, like an iconic image from a trip or a family gathering. I'm showing you here a picture from a few months ago when my lab, my wonderful, fantastic research team, presented me with a surprise gift. But our visual system is also quite fragile. And a lot of people struggle with often irreversible and progressive loss of their visual function. For example, the common disease glaucoma, which often results in the loss of peripheral vision, like I've tried to simulate here. Understanding and addressing this problem is a major focus of my research. So what's going on? Well, the eye, as some of you may know, collects visual information, bouncing off objects in the environment around us, focuses it through the cornea and the lens onto light-sensitive neural tissue at the back of the eye that we call the retina. But this is only the first part of a cascade for us to be able to see. If we think of the eye like a camera collecting the visual information, then the next step is all of that information has to be collected and sent down a cable, what we call the optic nerve, to a computer, the brain, that processes and interprets that image. So a defect anywhere along this cascade can and does cause loss of sight. But one area that's particularly vulnerable is the place where that cable connects to the eye. If there's a defect or some damage there, then the eye might still be collecting that visual information, but it can't reach the brain, hence the loss of sight. And that's essentially what happens in this disease, glaucoma, which is a leading cause of blindness and vision loss, affecting nearly 100 million people worldwide and over 500,000 people in Canada. It is very much a neurodegenerative disease, and I've put up here a wonderful image from the Donald K. Johnson Eye Institute's clinical side of a patient's retina and optic nerve in which the degenerating fibers are outlined in red. Although it is often associated with increased pressure in the eye, and some of you may remember getting an eye exam with an air puff test, that's what it's testing for, is increased pressure, but the actual underlying molecular and biochemical causes of this disease are very much unclear. And unfortunately, like most other neurodegenerative diseases, there is no neuroprotective treatment and there's no cure. So how is my lab trying to address this? Well, I have a background, I spent a few years in the pharmaceutical industry, and I'm interested in medicines that address the underlying root causes of disease, and not just alleviate symptoms, just as another callback to the slide that JD put up at the very beginning, but with respect to visual function. And so I'm very familiar with this fairly well-established pipeline or pathway of drug discovery that is very difficult and challenging. And we are interested in pushing some of our discoveries along this pathway, but often the most challenging, the most uncertain, and the most creative part of this process is the first part. And that is the idea or the step of understanding a disease process better in order to identify new targets that would interfere with that disease process. And an institute that is a research hospital like this one is ideally poised to make those kinds of discoveries. So at this kind of institute, my lab team and myself are free to interact with and collaborate with basic, or I prefer the term fundamental scientists, there's nothing basic about it, and clinical scientists, whoever we need to, including some of the other speakers that you've seen earlier today, to push new platforms and new technologies, create new technologies, whatever we need to do to advance the project. And so what our lab does really is set up our own mini pipeline of research platforms. We study disease mechanisms by profiling tissues. So for example, in this case, I'm showing you a slice of human optic nerve and retina in which each colored pixel represents the activities of 20,000 different genes that we can separate out in terms of their functions and try to understand the chemical signals in which all those cells are talking to each other. Then we try to boil all that information down into new insights, into what's going on in the disease process. And here I'm showing you some retinal neurons that have been treated with a molecule that we discovered that helps protect them from different types of injury. And then finally, we try to go back into preclinical models of disease and generate proof of principle that these molecules, or that this approach would work to treat the underlying disease mechanism. So in this case, this is a graph of declining retinal function with a solid line, and where we've treated with this molecule in the shaded area, that declining line has been stopped with the dotted line. So with this strategy, I'm optimistic that our approach has developed and uncovered new targets that I'm really excited about, that have the potential to prevent vision loss in patients. And also because of that brain-eye connection that I talked about, we believe that a lot of these targets may be relevant to other neurodegenerative processes as well. Thank you so much.
Thanks very much, Jeremy. So I'm curious to know, what would be one very important discovery in glaucoma research that you are working towards?
Thank you so much for that question. So I mentioned that it's a complex disease, and it's so complex that I think a lot of experts would call it an umbrella term for a collection of different types of diseases that all end in the same spot. I think this is often the case in pathobiology, the biology of diseases. And so what, to me, is a holy grail is to discover the first common incident or cause of damage that all of these different subtypes all experience, because that's what you would want to go after so that you could actually treat all the patients. So anyone who has this disease, this cure or this treatment would be effective for. So that, to me, is the key. And for what it's worth, my money and a lot of our lab research effort is looking at the neuroinflammatory signals that happen early in this disease process, which is what we think is one of the earliest events that happens.
Great. Thanks very much. Jeremy Sivak, thank you.